Hey everyone, and welcome back. Before we begin here today, please make sure you like and subscribe to our channel because it really does help us out. And in doing so also helps us reach others in need of assistance with these topics. So today we're going to be going over trigonometry, and we're going to be talking about the cosecant, secant, and cotangent and right angles. Now, what we're going to do here is we're not going to actually solve for the angle itself using inverse trig functions. We're just going to set up what the cosecant of the angle is equal to, what the secant of the angle is equal to, and what the cotangent of the angle is equal to. We will have later videos coming out where we actually solve for that particular angle theta shown there in that right triangle. But today we're just going to go over what actually are these three trig functions and how you set them up. So when you're utilizing trig functions, we want to know three things about the triangle and the angle that we're looking for. So for our angle theta here, we need to know what the adjacent side is. We need to know what the opposite side is. And we need to know what the hypotenuse side is. So with the adjacent side, we're going to label that abbreviated as A, opposite as O, and the hypotenuse as H. Now, looking at our angle theta here, the adjacent side will be the side, the shorter side leg that is attached to the angle or where the angle is being measured from. So we have two legs, one over here and then one unknown on this side. And then we have the hypotenuse, which is the largest side. So the legs are the two smaller sides and the hypotenuse is the longer side. The adjacent side will be the shorter leg or the shorter side, which is the leg of the right triangle where the angle is being measured from or where the angle is touching. So in this particular triangle, our adjacent side is 4. And then the hypotenuse side doesn't matter where the angle is. The hypotenuse side is still going to remain the longest side of the triangle, which is the side that is opposite the right angle here. So in this particular triangle, our hypotenuse side is 6. And we don't really know what the opposite side is right here. It's unknown at this point. So we can easily find that. And the way you find that, and way you find any side for a right triangle, if you have two sides but not the third side, is that you're going to use Pythagorean Theorem, which is essentially a squared plus b squared equals to c squared, where the side A and the side B are your adjacent and opposite sides, or your two legs of your right triangle, and then C is your hypotenuse side. So let's go ahead and just throw in our abbreviations and substitution here for this Pythagorean theorem. And we would have our adjacent side plus our opposite sides equals our hypotenuse side, which each of those individuals being squared. So what we can do here is we can rearrange this and we can solve for the opposite side of this triangle using this theorem. And what we're going to have here is that we're going to have our opposite side is equal to the hypotenuse side squared minus the adjacent side squared. And if we really want the true opposite side by itself, because this is still a squared version, we would just take the square root of everything on that right side. So we do know what the hypotenuse side is, which is 6. We know what the adjacent side is, which is 4. So we can just plug into this equation. So that'd be the square root of 6 squared minus 4 squared, which gives us the square root of 36 minus 16, which is the square root of 20, which roughly pops out to be 4.47 for our opposite side here. So this side right here is 4.47. All right, so now with our opposite side, our adjacent side, and our hypotenuse side known, we can move on to actually showing the calculations for the cosecant, the secant, and the cotangent for the angle. Once again, we're not going to be solving for the individual angle. Those will be in later videos. We're just setting up what the cosecant, secant, and cotangent of the angle are equal to. So the first one, which is the cosecant of our angle, which is abbreviated as CSC of theta, that is equal to the hypotenuse over the opposite side of our angle. So if you remember, or if you watched our previous video on this where we were talking about sine, cosine, and tangent, well, the cosecant is essentially 1 over the sine of theta. Because sine is opposite over hypotenuse, cosecant is just the inverse of that, where it's hypotenuse over the opposite side. And then our secant of our angle, which is abbreviated as SCE, is equal to the hypotenuse over the adjacent side. So once again, if you remember from sine, cosine, and tangent, well, the secant of the angle is essentially 1 over the cosine of the angle, because cosine was adjacent over hypotenuse. 1 over that gives us hypotenuse over adjacent, which is the secant. And then you're probably going to guess what the cotangent is equal to. Well, the cotangent of our angle is abbreviated as COT of theta, and that is equal to the adjacent over the opposite, which essentially means that the cotangent is 1 over the tangent of the angle theta, because the tangent was the opposite over the adjacent, so the cotangent is the inverse of that. So let's go ahead and find out what each of these in terms of the angle are equal to for this particular triangle. So looking at the cosecant, well, the cosecant of the angle theta is equal to the hypotenuse over the opposite side. Well, the hypotenuse is our 6 for this particular angle, and the opposite side is 4.47 because that is the side that is opposite the angle. The angle is not touching that side at all, so it is the opposite side. So we will just plug in here of 6 over 4.47, and you could leave it as this fraction, or you could write it in decimal form, which 6 divided by 4.47 gives us 1.34. And that would be our cosecant of theta. Once again, not finding the actual angle of theta, which we could, but in this case, we're just writing out what the cosecant of that angle would be equal to, which is 1.34. Alrighty, let's go on to the secant of the angle, which is the hypotenuse over the adjacent. Well, the hypotenuse is still 6. The adjacent is 4, since the angle is being measured from that leg. So once again, you could leave it as 6 over 4 if you wanted to, or you could write it out in decimal form as 1.5. So the secant of the angle theta is equal to 1.5 for this particular triangle. And then lastly, looking at the cotangent of theta is equal to the adjacent over the opposite side, which the adjacent side is 4 over the opposite side, which is 4.47. Once again, leave it as that fraction or write it in decimal form of 0.89. So that is how you would solve for the cosecant of an angle, secant of an angle, and the cotangent of that angle for a right triangle. This is just showing you what those functions of that angle are equal to, not actually finding the angle itself. That will come in later videos. This was just more of an explanation video of what these 3 trig functions are and how to use them. So I hope this video was helpful in explaining what the cosecant, secant, and cotangent are relative to a right triangle. If you want to see more problem solved this Friday, please check out other videos on our channel. As I mentioned earlier, that we will be uploading more videos talking about these angles and these trig functions. Also, if you haven't done so already, please make sure you leave this video a like, subscribe to the channel, and if you can, leave a positive comment for us because it really does help us out. Thank you for watching, and I hope you have a fantastic day.